Welcome to Lesson 39, Cramer's Rule. So we've been solving systems of equations. We did the graphing method. I love doing that first because it kind of shows you what's going on, looking for the intersection point. It's not the most practical for if you want to find exact solutions particularly. But then we had these two other methods which are kind of nice, the substitution method and the addition method. And the great advantage there is you can get some actual exact solutions. But what we want to do now, where we're heading now, is we're trying to come up with a standardized way of solving these things. Because with the addition method, you're kind of like looking at it saying, what should I do? I guess I'll multiply this equation by -2 and all this equation. Substitution method, you're like, maybe I'll do it, Anyway, we're trying to come up with something that's so standardized that it becomes almost like a recipe, like a rote method. Like, hey, do this, do this, do this, do this. That's what we're aiming for. So our first step in aiming for it is today, Lesson 39, Cramer's Rule. And you can see right now, I wrote it down. It's a recipe, right? If you happen to have in this case, a 2x2 system of equations, just notice I'm not using specific numbers. I'm just saying ax plus by plus c dx plus ey plus f. In other words, a, b, c, d, e, f can be whatever numbers you want. So we're trying to derive like a formula almost. Well, there's a solution for x. Do this with the numbers. And here's your solution for y. Do that with the numbers. Of course, I probably have to explain what the heck are you looking at over there, right? These things, by the way, are called determinants. And of course, I'm going to have to show you what you do with those. A determinant is something that you have to evaluate. They boil down to a single number. And I'll show you how to do that. Boil down to a single number. So you can evaluate, you arrange these numbers. There's a certain dance step you're supposed to do, and that'll become just a certain number. So in other words, what we're saying is that x is some number over some other number, and y is some number over some other number. It is the solution written out. Okay, so again, I need to explain how the heck you do it. But first thing I want to say is setting up the solution is kind of nice. Okay, what do we got here? 3x minus 4y. That's my a, that's my b, right? That's my, so that's a c. That's my d, that's my e, and so on. So do you see these two determinants here? They got the a, the b, the d, the e. That basically means, and now let's write this a little more neatly, that basically means that to make the denominator at least, you're just grabbing the coefficients right there. Not the x and the y, but just the actual coefficients. A 3, a -4, a 5, and a 6. Just grab those numbers and set them up like that. As for the solution for y, you've got exactly the same thing in the denominator. A, B, D, E, A, B, D. It's the same. So you can just copy that over. Okay. Now, there's a certain pattern here that once you get the pattern, you'll never forget it. But in order to solve for x and in order to solve for y, you'll notice that we have more of these determinants to make. But here's where we start using these numbers, the numbers on the right. If you think of this as sort of an x column and a y column, just loosely speaking, an x column and a y column, then if you're solving for x, you put the 5 and the 8 in the x column. If you're solving for y, you put the 5 and the 8 in the y column. In fact, you know what? I think I'll do that in a different color just to emphasize. I'm taking the 5 and the 8. I'm taking it in such a different color. Okay. And I'm putting it in the x column, so to speak. I'm putting them in the y column, so to speak. How do you fill in this? You just look at what's underneath there. Grab the same things, -4 and 6. How do I fill in this? Just look what's underneath there, a 3 and a 5. Put the same things in there. So, believe it or not, we just wrote the solutions for x and y. Okay, so it's kind of a fun dance steps is the best thing I can think of here. It's like you're just kind of you're definitely following a recipe of sorts. By the way, let me make sure that looks like a -4. Okay. Now, how do we evaluate the determinants? Well, this is where we need to ask Zorro for help. So let me take the one that's on the bottom Okay. Now, in order to evaluate that, what you do is you swipe with your sword, and you go 3 times 6 is 18, right? Then you subtract, swipe down the other way. So it's not quite Zorro. The Zorro makes a Z, right? This is not a Z. This is an X, but I always think of the swords going foot. So 3 times 6 is, you do that first, and then -4 times 5 goes over here. So just be a little careful. That's an 18, and that's minus a -20. So it's 18 plus 20, really. So it's 38. So this is just a 38. This is the same thing, so it's also a 38. Okay, that's how you do it. Multiply down the diagonals. So it's like, once more, it's dance steps to get used to. Let's grab this one here. I got a 5, an 8, a -4, and a 6 arranged like so. Why am I having a hard time making -4s today? Anyway, you do the old foot. 5 times 6 is 30. Minus. You always do minus. So it's something minus. Okay, always do minus. And then, what have I got? I've got a -4 times an 8. So 5 times 6 is 30. I kind of did that. Minus a negative is plus. So that makes a 32. 30 and 32 is 62. So that's what goes up here is a 62. One more determinant. So just taking this one, 3, and then to get like this, right? Okay, so again, once more. 3 times 8 is 24, minus, and then in this case, 5 times 5 is 25, so we're getting a -1. Huh, how do you like that? Okay, so what are our answers then? I guess I'll go back to blue. So x is equal to 62 over 38, which I can cancel 2's. 31 over 19. Did I do that right? Yeah. 31 over 19, whereas y is equal to -1 over 38. I should see if I've done this one before. 31 over 19, -1 over 38. Hey, I got the right answer. Isn't that something? So, isn't that kind of fun? The interesting thing is there's no guesswork anywhere. There's almost like no art required anywhere. It's just follow the steps, man. Follow the steps. Set up the determinants the way you're supposed to and evaluate the determinants the way you're supposed to, and boom, you got your answer. So what do you think of that? Nice method. Here's one you can try yourself real quick. Just pause the video, give it a twirl. You back already? Okay, well, let's set up the determinants. Now, I didn't copy the formulas here because what's nice is when you can set this up. In fact, let me give myself a little more space here. So when you can set this up kind of just by dancing. So remember, the first thing you do is you grab these numbers on the left. Those are going to go underneath here like this. And you take them in the same sense that you see them. A 2, then a -3, then a -5. That's a 3. A 2, then a 3, then a -5, then a 6. Same thing on the bottom here. And if you want, we can evaluate it while we're sitting here. So while we're sitting here, 2 times 6 is 12, minus, and 3 times -5 is a -15. So it's 12 minus a -15. It's a 27. This is a 27 on the bottom. This is a 27 on the bottom. Okay, back to our numerators. So we're going to make determinants up here as well. And this is the part where you get out the different color pen. I'll do the red, I guess. This is the part where you take those numbers, the 4 and the 8. When I'm solving for x, they kind of go in the x column. When you're solving for y, they kind of go in the y column. Okay, so that's what I did with those numbers. And then what goes next to the 4, 8, just look underneath here and say, oh, I see a 3 and a 6, and then bring it up. What goes over here? Well, I see a 2 and a -5 down there. Just bring it up. Now we need to evaluate those two determinants. So this one, I'm just going to try to fit it in up here. 4 times 6 is 24. Minus 3 times 8 is 24. How do you like that? We got 0. Okay, I'm just checking myself right here. 4 times 6 is doing. It is what it is. X is 0, folks. 0 over 27 is 0. How do you like that? I wasn't expecting that. Anyway, then in the y column, what do we got here? We got flip. 2 times 8 is 16 minus 4 times negative 5 is negative 20. So it's 16, basically plus 20 is a 36. And so y is equal to 36 over 27. Let's see, can we cancel something? How about 3's? 12 over 9. How about 3's again? 4 thirds. So y is equal to 4 thirds. X is equal to 0. Y is equal to 4 thirds. Is that what I got before? That's not what I got before. 2x plus 3. Oh, that's because I changed the problem. Okay. Well, of course, the way to check your answer is to kind of go like this. Plug it into the original. 2 times, you're saying x is 0. Okay. Plus 3 times, you're saying y is equal to 4 thirds. Does that equal 4? 3 times 4 thirds does equal 4. It satisfies the top equation. Now, does it satisfy the bottom equation? Negative 5 times, you're saying x is 0. Plus 6 times, you're saying y is 4 thirds. Does that equal 8? 6 times 4 thirds really is 8. It's 24 over 3. It really is 8. How do you like that? We solved it. It's kind of a weird solution, but we solved it. Okay, so I hope you're kind of grooving up on this. A lot of times when I show people Cramer's rule, that's all I get out of them the rest of the course. Although I should qualify that statement. That's all I got out of them for a 2x2 system. This works really well for a 2x2 system. What if you had a 3x3 system? Well, if you had a 3x3 system, it's actually really easy to write what the solution should look like. See? That's what the solution should look like. Yeah, there you go. It's not quite as easy to actually do it. Now, the first thing I want to show you is how easy it was actually to write the solution. Let me come back for a second here. Remember what we did? We took all these numbers on the left, and they ended up on the bottom, right? Same thing here. All these coefficients on the right, the a, the b, the c, the a, the b, the c, the e, the f, the g, the e, the f, the g, the I, the j, the k, the I, the j, the k. There's the same as the same as the same as the same. So see, it's the same kind of pattern. So you take all your coefficients from the left side, put them in this box, so to speak, and that box is in the denominator for your x, for your y, and for your z. How do you determine it? How do you evaluate a 3x3? We'll get to that. But then the other thing that's the same is, you see the DHL. Whoops, let's not use that. You see the DHL. If I'm solving for x, I put the DHL in the x column. If I'm solving for y, I put the DHL in the y column. And if I'm solving for z, I put the DHL in the z column. What goes here? BFJ. BFJ is here, so BFJ is here. CGK, CGK, yep. AEI, AEI, yep. CGK, yep. AEI, yep. So you see, it's exactly the same kind of dance steps to put together the solution. And by the way, you could scale up and do a 4x4, a 5x5, a 6x6. It's easy to actually write this part. What's hard is trying to evaluate these determinants. So we can do it. It's doable for a 3x3. I wouldn't want to do it 4x4 or anything bigger. But you can do it for a 3x3. I should at least show you that once. You should go through this at least once in your life. Solve a 3x3 determinant. You can join the club then. You can say, hey, I did 3x3 determinants. Right? It's like a status thing. Anyway, okay, let's maybe not solve for, should we solve for everything? Let's at least solve for x. We'll solve for x and see how much energy we got left. So I'm going to solve for x here. So remember, I'm taking all my coefficients from the left side. So I'm looking here and I'm seeing in this column a 3, a 7, a 2. I'm looking here, I see in this column a -4, a 2, and a 3. And I see in this column a 5, a 1, and a 4. Okay, and then what's going to be on top is, this is the part where you grab these numbers, 8, 8, 12, and you put those into the x column. And then copy up these other numbers, the -4, the 2, and the 3, the 5, the 1, and the 4. Let's make that 2 a little bit bigger. Okay, so this is our solution for x. We got to figure out what does that determinant come out to, and what does this determinant come out to, and once we get those two numbers, one over the other, that's the solution for x. So here's how you do it. You go like this. Start up here. Take the 3. Then you make a little 2 by 2 determinant. How? Grab these numbers. The 2 and the 3 in this column, the 1 and the 4 in this column. Okay? So it's kind of interesting how you do this, right? You take this number and then you make the 2 by 2 with the numbers that are underneath it. Not right underneath it, but the ones that are sort of crookedly underneath it, or whatever you'd want to say. So, okay. Then you subtract. Now what? Well, we got to move over to the next number. Put a -4 there. And then take the numbers that are underneath, but not directly underneath, those numbers in other words, and set up a little 2 by 2 over here. 7 times 2 times a 1 times a 4. Okay. Then you add. So that's important. Minus and then plus. You have to alternate like that. Now what am I going to do next? Well, I'm going to take this 5 here. Make another 2 by 2 with, can you guess? Those numbers. So the ones that are not quite under the 5. They're kind of crookedly under the 5, however you want to say that. So there, that 3 by 3 determinant is evaluated by basically putting together a string of 3 different 2 by 2s. Now the good news is 2 by 2s aren't so bad. So I got a 3 times, and let's just see if we can kind of do this in our heads more or less. 8, well maybe I won't. 8 take away 3, right? So those are my two, I don't want to call them cross products, that seems to mean other things, but those are my two Zorro sword swips. Now this minus a -4 becomes plus a 4. And then what I got here, 28 minus 1 times 2 is just 2. Okay. Plus a 5 times 21 minus 2 times 2 is 4. Okay, so I got 3 times 8 minus 3 is 5. Plus 4 times 28 minus 2 is 26. That's a 4. And then plus 5 times 21 minus 4 is a 17. So 3 times 5 is 15. 4 times 26 is, I want to say, 104. And then plus 5 times 17 is 85. So we get 204. Huh. Nice number, huh? Okay, so that's what goes on the bottom. Let's start setting ourselves up here. X is going to be something over 204. Have I got an answer for this one? It'd be nice if I did. I only wrote down the final answer. Well, okay, let's see what we get for the top determinant. Get a different color going. On the top, so again, you start with the 8, and then you take these numbers and put up a 2 by 2. A 2, a 3, a 1, and a 4. Okay, and then you minus. Remember, we're going to alternate like we did over here, a minus and then a plus, right? So then we minus. Minus what? Well, you come over to the next number, which is actually also a minus. Build your 2 by 2. Use this number, this number, this number, this number. Use the 8, the 12, the 1, and the 4. And then you alternate, so make that a plus now. And you're grabbing the 5, and you're making a 2 by 2 from these numbers. So the 8, the 12, the 2, the 3. Okay, cool. Now we just got to kind of do it. 8 times, get the Zorro going. 8 minus 3. Minus a minus makes a plus 4 times. 32 minus 12. Plus 5 times. 24 minus 24. Okay. 8 minus 3 is 5. 8 times 5 is 40. 32 minus 12 is 20. 4 times 20 is 80. And then this is basically 0, because 24 minus 24 is 0. So we end up with a 120. Interesting. So I got a 120 on top. What does this reduce to? Well, I'll at least cancel 2's. 60 over 102. Now I'll cancel 2's. 30 over 51. Now I'll cancel 3's. 10 over 17. And I think that's as low as I'm going to go. And that's what I got before. I'm so happy. Good. I don't seem to be making any mistakes on this, so that's good. So I don't know that we really need to solve for y and z. You do the same things, but if you did want to do this as an exercise, for y you should end up with something that reduces to 16 over 17, and with z you should end up with something that reduces to 2. Okay. So like I say, this Cramer's rule, it's really nice for 2x2s. It's really not bad for 2x2s. For 3x3s, yeah, you could do it. It's a little more work. At least it is a recipe. So if you like following, step 1, step 2, step 3, step 4, then it's not bad. Cramer's rule for 4x4, I don't think it's going to take much convincing for me to say let's not. Because it's easy to write the solution, right? So what would you have? An AX plus a BY plus a, well, you'd have to go beyond Z. Let's start a little earlier in the alphabet. Like W plus BX plus CY plus DZ equals E. So that's 1, 2, 3, yeah, that's 4 unknowns, W, X, Y, Z. So that would be one equation, and then you'd have, let's see, where are we? FW plus GX plus HY plus IZ equals J. And then you'd have KW plus LX plus MY plus NZ equals, that's supposed to be an O, not a 0. PW plus QX plus RY plus, that's an ST equals a U. But at least you know how to write the solution, right? What's the solution for X? Well, you'd set up a 4x4. A, B, C, D. Again, I'm looking at just the coefficients on the left side here. F, G, H, I, K, L, M, N, P, Q, R, S. Yay! And then to solve for X, you would grab, you would grab these numbers and you would put them in the X column. E, J, again, that's an O, not a 0, U. And then all these other things would be the same as what you had underneath. So B, G, L, Q, let's go, C, D, G, H, I, G, L, M, N, Q, R, S. There! Now, if you want a clue how to solve the 4x4 determinant, it goes like this. Just like this. You would take A times this 3x3 minus B times another 3x3 plus C times another 3x3 minus, notice the alternating, minus, plus, minus. Then you would have a D times another 3x3. Okay, I don't want to write it out. You don't want me to write it out. You don't want to watch me write it out either, do you? No. I will never ask you to do a 4x4, so don't worry about it. But the point I wanted to make was that, it really is kind of nice and easy to write out the solution, sort of. I mean, in some kind of a mathematical sense, this is the answer. We wrote these things. There's a recipe for evaluate. That's the answer for X. So in some sense, yeah, we found something. We found a recipe method for solving systems of equations. It's just that it's not really that practical. It's not that practical. Unless maybe you're just doing 2x2s. So to end this, what I want to do now, and this is optional, you can quit now if you really want to, but I just want to give you some idea, like, where'd they get these determinants? Why are they doing the determinants? I don't understand the determinants. Well, here's where the determinants come from. So start over. Let's just do a 2x2. AX plus BY equals C, DX plus EY equals F. We're going to solve this by adding, because we know what that method's all about. Got to make equal and opposite coefficients. Do you want to solve for X? Do you want to solve for Y? I guess I'll solve for X. So I'll say solve for X by addition. So if I'm solving for X, it means I'm supposed to make Y go away, right? So look at the two coefficients on Y. I got a B, I got an E. What I'd like to do is make one of these into a B times E. So I'll multiply that by E, so this will become a B times E. And then this one I'll multiply by a negative B, so that'll be a negative B times E, and then I can add and they'll cancel. So I'm getting ready to cancel Y's. So the top equation multiplied by E, I get A E times X plus B E times Y equals C E. Underneath I got negative B D times X minus B E times Y equals negative BF. Yay. Add your equations together. You've got AE minus BD. That's the coefficients, right? You can just combine your coefficients. AE minus BD. X. The Y's go away. Yay. And over here we'll have a, what do we got? A CE minus a BF. So the solution for X looks like this. CE minus BF over AE minus BD. We solved for X. Where are the determinants? Well, the guy invented, this Cramer guy, invented the determinants by saying, what is this? AE minus BD. Oh, for goodness sakes, that's going like this. AE minus BD. Hey. Cool, right? AE minus BD. And then you look again and let's get a different color maybe. What's a good color? I'd do this one, I guess. Then you look at the top, you say CE minus BF. How would you do that? Well, there's the C times the E and BF. That would be the B times the F. So it's a different cross order. It's as though you took this column and you put it here so that you would have a C times an E. Yep. Minus a B times a D. Yep. So it's just a pattern that the guy recognized, I guess. He said, hey, man, look, I solved it by addition. This is where formulas come from. Someone says, well, I don't know what the numbers are yet, so I'll just use letters. I'll solve it with all my letters. And then you look at the letters and you say, oh, wow, that's cool. There's my formula. So if you want, you can use this formula. You could say X is always going to be equal to CE minus BF over AE minus BD. But the shortcut way of saying that is the old, determinant stuff. Because the whole idea of the instructions... The whole idea of the determinant, your instructions are take this times this minus this times this, just like it looks here. This times this minus this times this. I just think that's kind of slick. So we're going to practice the Cramer's rule a little bit. And actually in the next 2 lessons, I'm going to show you an even more powerful standardized procedure for solving systems of equations. But that's later. That's not yet. All right, my computer turned off. Come on, you.